All right. So 1, 2, 3 for D. For a quadratic, oh, too thick a head itches. This backfired miserably. Quadratics have what is a minimal x-intercept? 0, because they could be completely above or completely below, correct? And what's the maximum number of x-intercepts a quadratic can have? 2, and then 1 as well, because its vertex can land on the x-axis. So this one is D. And then linear has, okay, it joined us. Linear has minimum 1, maximum 1. Only 1, right? It's going to cross through and it just goes. Okay, determine the following characteristics of the polynomial function. Now, when you go to sketch this, I'm going to explain it to you, because the sketching, sometimes it's scary. So, the number of x-intercepts. How many x-intercepts does this one have? When you type it in, how many does it actually have? 1, right? So we go x cubed. So it says number of x-intercepts. So I say 1. I don't say what it actually is, correct? Because it says number. You have to read thoroughly. The next one says y-intercept. It doesn't say number of y-intercepts. So what's the y-intercept of this one? -5, because it is the constant at the back. Now make sure you put it as a coordinate, because it's a coordinate. Y-intercepts and x-intercepts are coordinates. What's the end behavior of this one? I don't even need to type it in. What's my end behavior? It's a positive x cubed, so it's up on right. And because it's a degree 3, it's down on left. What's the domain of a cubic if it's not a word problem? XER. What's the range? But it's discoing. What's the range? YER. How many turning points does this one have? It has 2. Because remember, max and mins are 2 turning points. Points of inflections are no turning points, correct? Now, if you go to map these, or go to graph these, this is not the best graph to put it on. But if you go to graph these, I want you guys to help me find the max and min. So go to your calculator, type it in. You're going to get me the max and the min as a coordinate. And I know I have a y-intercept at 0 and -5, so I can plot that. The maxes and mins you have to find specifically using your calculator, because even if you use your table of values, often they don't land in your table of values, right? They're decimal numbers. So everyone should be trying it out. Your y minimum needs to be lower than -10. This is your minimum, I believe. So for the minimum, I get approximately 2.67 and -14.48. Did you get that for the minimum? And then the maximum, second trace 4. The maximum is at, okay, look at this one. Everyone go to the maximum. The maximum says 1.1541 e to the -6. So e to the -6 is just 0. E to the -12, 0. E to the -bajillion, 0. E to the -4 rounds to 0. Okay? So e to the negative to anything is 0 and -5. What do we know about this graph? Its maximum is actually the y-intercept. How can I get more points to draw? Second table, right? And then I can pull a whole bunch more points off of it. These are all really large, so this is not the best actual table for it. But you can plot points off of there, correct? Do I have to? Now, these ones are actually labeled as -6 to 6, so I would have to label them that way. This is a really bad Cartesian plane for this. But if it's not labeled, do I have to make them worth 1? No. I can make my y scale 4 or my y scale 5, right? And then do it at my own pace so that it fits. Okay. What's the trend of this data? Describe the function. What do you think it is? Linear, quadratic, cubic, logarithmic, exponential? What do you think this is? Degree of the function. Yeah. Dang nabbit. Coming back. Oh, it's a good one. Okay, the volume of the water in a cylindrical water tank being drained can be modeled by this function. It's draining, right? So it has a certain volume and then drains. Where V represents the volume in liters, so Y is V, and I always do this, I help myself out. So I know Y is V, is the volume in liters, and T is in where X would be. So T is X, and it represents the time in minutes. So I help myself out and know which is Y and which is X, because that's more helpful to me. How long will it take for the volume to get to 0 liters? What did they give me, X or Y? They gave me Y, because volume, and if they don't know, they gave me the units, volume in liters. So they gave me Y2 is 0, Y1 is this. Now, we can solve this algebraically, but I'm going to go through it with your calculator just to see if you guys can do it. My y-intercept is at 225, correct? So that's the volume of the tank full. So my y max needs to be bigger than that. So everyone should be typing it in. Type into your calculator, negative 3.8 t, or x, plus 225. And your window, your y max needs to be at least 225. I'm going to make mine be 230. And then press graph. And I want it to hit 0. So 10, it's not hitting 0. It's way the heck up there. So I'm going to go maybe make my x max be 100. Can I see it cross? Yeah. So I made my y max be 230, and I made my x max be 100. And then I can make my y2 be 0 if I want to. And then just find out where they intersect. Second, and remember, if you want, you can make your y2 be thicker, right? So go second trace 5, enter, second trace 5, enter, enter, enter. And I get to the nearest minute, 59. Did you get that? Yeah. Yeah. It should say get to at least. I don't like when they don't say at least and at most. It actually makes it harder for you guys grounding rules. If it says the volume get to 0, it would technically take 60. Because it's 59.2. $16 minutes. You're right. You would have to round up. I like when they use like has to hit at has to, yeah, well, how can you say at least 0? It's 0. At most 0. Doesn't make any sense either. Just 0. Okay. This one, what's the degree of this function? Looks like a straight line, doesn't it? Just degree what? 1. Is it increasing or decreasing? Okay, for this one, it wants x-intercept, y-intercepts, mins, max, trend, and data, domain, and range. So it's a cubic function, correct? If you type it in, you'll know it's a cubic function. But even if you don't, this is x, this here, y equals x, x minus 3, x minus 3. That's technically what you have when it says squared, right? And then x times an x times an x is an x cubed. So this is cubic. I wanted to give it to you because we haven't given ones with brackets before, so I wanted you to be able to have seen that. So we could type it in just like that, x bracket x minus 3 squared, and press graph. I'm going to zoom 6. Go back to my standard window. So the great thing is when they're in brackets like this is they actually give you the x-intercepts. They're just the opposite of these. You can use our calculator to get them too, but this one is x equals 0, and this one is x equals 3, and there's 2 of them there. So it makes it bounce. So if you look, you'll see at 3, 0, you actually have a minimum. Because you'll get a point of tangency here. So it bounces on the x-axis when you have 2 there. Still the multiplicity too, but they don't really ask you for that in 30-2, but I'm going to say it anyways. more so in 30-1. Okay. They want the X-intercepts. So these are our X-intercepts. Am I allowed to short form like this on a test? Nope. What's my Y-intercept at? Some people will tell me it's -3. Is it really at -3? No. Now, how to find your Y-intercept once you have it in your calculator is we just know when it's a Y-intercept, X equals 0, correct? And how can we put in X equals 0? Well, we can go second, trace, value, X equals pops up, and we can put in 0, and you get 0. So this one's at 0, 0. You also see it here, right? The minimum is at 3, 0. And the maximum, second trace max, is at 1, 4. Because it is not a word problem and it's a cubic, my domain is XER, my range is YER because it discos. Does some funky little things in the middle, but it still discos. One arm up, one arm down. This one is, I only give this one because it's a bit tricky. I've never seen them give something like this tricky on the diploma, but I wanted you to be able to never get a question that you haven't seen something like it before and then make a mistake because I haven't shown you. So here it says, a snowboard company uses the relation P of X equals 210X minus 60X squared to model its profits. In the model, P is profit, so P is profit, and that's here, so P is Y. Profit in thousands of dollars, so whatever Y value you get, like say it's 30, that's $30,000. Say you get 100, that's $100,000. So it's saying the profit is in thousands of dollars. So whatever you get, you would actually put 3 zeros behind it. So they're making it so that the equation isn't so ginormous. It's thousands of dollars. And X is the number of snowboards in thousands. So if you get 3, that's actually 3,000 snowboards. And so that they don't have to give you a giant equation. Your window doesn't have to be ginormous. Okay? So here it says, how much profit, so we're going to type this into our calculator, every single one of you. Type it in. 210x minus 60x squared. Now this is where you're going to error if you didn't read it. And I'm going to assume most people erred because I haven't given you a question like this before. But it says how much profit, so they want Y, should the company expect if they manufacture 2,000 snowboards? Well, X is the number in thousands. So this isn't X equals 2,000. That would be wrong. It would be X equals what? 2. So I go second, trace, value. Do you see how the window can be substantially smaller this way? That's where they do the thousands. It's to be nice. Although people don't like it. So I get P equals, or P of X equals 180. Well, what is that actually? What's the profit? The profit the company should expect if they manufacture $2,000 skateboards. Is $180? Does that even make sense? No, it's 180,000, right? Because the money is in thousands of dollars. Then B says the maximum profit of snowboards sold can be found by using what point on the graph? Maximum profit. Profit is X or Y? Y. So we need the Y value. And whenever it uses the word maximum or minimum, it's literally telling you to find the max or the min. The problem with the max or the min is you always have 2 options, right? You get profit or you could get maximum number of snowboards, right? Both options. So we just have to see what it says. So they want the maximum profit of snowboards sold. So we want the Y value of the maximum. If they ask for the maximum number of snowboards sold, snowboards, yeah. we would just take the x value of the maximum, right? So we need the vertex. More specifically, we need the y value of the maximum, or the y value of the vertex. They'll more specifically ask that even. Which of the following would most likely represent a cubic? A. That's sinusoidal, you don't even know about it. This one's exponential and that one's linear. So it's A. B is sinusoidal, it keeps going. Even though it kind of looks like it's cubic, it's not. C is exponential, and D is linear. This one says, identify the correct polynomial function for this graph, justify your reason. So this one here, for the first graph, graph 1, what kind of graph is that? It's a quadratic, which means it's a degree 2. It's also up on the right and up on the left, so I have a positive leading coefficient. And what's my y-intercept? 4. So I'm going to look at the quadratic options. It has to be concave up. Is this one concave up? No, because there's a negative leading coefficient even though it has a positive 4. So people will draw themselves to this one. It's actually this one. It matches 4 because it has a y-intercept at 4. And how do we know that? Well, when we want y-intercepts, we just plug 0 in for x, correct? If there's brackets, remember I told you can't take the constant at the back if there's brackets? You can either expand it, or for y-intercepts, you can plug x equals 0 in. So we can go y equals 2, bracket 0 minus 2, 0 minus 1, and this is 4. So this has a y-intercept at 0, 4, like it shows it. It also has a positive leading coefficient, because I go 2 times x, that'd be 2x squared. So there's a positive leading coefficient. Also, these here are x-intercepts. So x minus 2 equals 0, x equals 2. So that's at 2, 0. And this one's x minus 1 equals 0, x equals 1. So when they're brackets like that, they actually just give you the x-intercepts really quickly. But most often we don't see them in brackets. But I just wanted you to see that form. Graph 2 is a cubic function. It's down on the right, so I need a negative leading coefficient, and it has a 0 as a y-intercept. So my constant, I shouldn't have a constant, right? So negative leading coefficient. And if I put this through, this 2 through, it actually is the same as saying 1/2 negative. I could go, I'll show you what I could do. I could go negative 1/2 in front, x cubed minus 4x squared, which if I distribute that through, is negative 1/2 x cubed plus 4x, 4 over 2, x squared. Well, 4 over 2 is just 2, right? So I could run it through, and it does have a negative leading coefficient, and its constant is 0. So 3 would be graph for B, and it's because it has a negative leading coefficient and a constant of 0. And then the last one is linear. It has a y-intercept of 0.5 and a positive leading coefficient. This is out of order. If I write it in order, it's x plus 1/2 or 0.5, correct? So there's a y-intercept of 0.5 and a positive leading coefficient. So it's going to be 4. Okay, the rest we're going to go over tomorrow. I'm going to hand out these exponential and log ones, that you have to practice on that today too. And we'll finish the polynomial tomorrow and log points tomorrow. Making sure we can do regressions as well while that's coming up. Here, this one for number 9 says, write an equation of a polynomial function that satisfies each of the characteristics, sketch and state the degree of the polynomial. So one turning point would be a quadratic, right? A maximum value and a y-intercept of 3. One turning point has to be a quadratic. Quadratics have one turning points, cubics have 2 or 0, and linears have 0. Okay? So this one has a maximum value, one turning point, and a y-intercept of 3. So I know that at 3 I have to have a y-intercept, and it has to have one turning point and a max, so it has to be concave down. So I could go, That is not, I don't even, I feel like magic right there was happening. So I could go like anything like this, as long as it's symmetrical, right? And then it says the degree is to degree 2. And explaining your reasoning, if there's one turning point, it can only be a quadratic. Because cubics have 2 or none. Linears have none. B says cubic, positive n direction, y-intercept of -4. So it has to end up on the right, down on the left, correct? And it's cubic, so it could do whatever we want it to. It just needs to end up here somewhere. So we could go just like this, and then curve, and then we could go, oh, that'd be a really bad graph. Pretend that's all on the thing. And then we're doing these regressions, so we're going to do regressions tomorrow. Big setting on regressions. So then we're going to go to what we were just on, logs and exponential. So Verna invested money in a bank account using the following equation. I set you up for this one. This one's a hard one. And I specifically set you up because I'm like, if you can do this hard one, you can do anything. Now, determine what the different numerical values represent. What's the 2,000? How much? What's this represent? Yeah. How much she invested, right? How much she put into bank account. Now what's this 1.06? 1.06 is greater than 1, so we know it's increasing. But what's it increasing by? This is the trick. It's not increasing by 6%. It's increasing by what? What did I do to get that 6%? Remember with compound interest? You do final equals initial, bracket 1 plus the interest rate divided by CP, and then n times CP, correct? Well, I have 2x here, don't I? So what is CP? In this equation, CP is 2, correct? So if my answer is actually 0.06, what was it? 12, because I divided by 2, correct? You see that? So the interest rate is 12% per annum. And then you can say because it was divided by the 2 compounding periods, right? And then the 2 at the top, the 2 represents compounded semi-annually. And they do this on the written response. They'll ask what do the values stand for. And you need to know. How many years to the nearest year will it take for the investment to double? Well, what was it originally? 2,000. So what am I asking for it to be? 4,000 equals 2,000. Bracket 1.06 to the 2x. Divide my initial over first, always when I have my final and my initial. And I get 2 equals 1.06 to the 2x. And then I can convert it to a log, correct? Every single time. So I can go log, the base is 1.06, because I get y, a, x, and then a log is x equals log base a of y. So it's going to be log base 1.06 of 2 equals 2x, divide by 2. You can also do your calculator, right? Log 2 divided by log 1.06 divided by 2, 6. 5.9478, which is 6 years. So could we y1, y2 it right here and find out where they intersect? Absolutely. Sometimes the windows are hard. So here it says Kira bought a piece of machinery valued at $250,000. So that's my initial. It depreciates, which means I'm going to do 1 minus, right? it depreciates by 12%, so 1 minus 0.12. How many years will it take to be worth 100,000? First thing I always have to do is divide by 250,000. Make sure you're not packing up. So I do 100,000 divided by 250,000, and I get 0.4 equals 0.88x. Then I can y1, y2, or I can convert it to a log, which would be log base 0.88 of 0.4 equals x, and then I just type it in. I don't have to worry about Windows even. I get x equals 7.16, so it would be 8 years, because it says less than 100,000. So it would take me till the 8th year to be below 100,000. Then we're flipping over. This one here says cobalt-60 has a half-life of 5.26 years. I actually researched that, which is kind of crazy. How long will it take? There's lots that have like 80 million year half-lives. So how long will it take to decrease to 30% of the original? So this is one of those that I said was a little harder, because they don't give you the original, but it's 30% of the original, so you can pick the original to be whatever you want it to be. So it has a half-life of 5.26 years. So that's the period. It halves every 5.26. It's asking me for t. It wants to decrease to 30%. If it's 30%, you can do 1 and 0.3, or I'm going to do 100 and then 30. It doesn't matter. The first thing you have to do is divide by the 100, your initial. So I get 0.3, don't know why I put it in brackets, equals 0.5 to the t over 5.26. Now I have y. I could y1, y2, but here I have y-a-x. And so I get x equals log base a of y off my formula sheet. So x is t over 5.26 equals log base 0.5, and beside it is 0.3. And then I just have to multiply by 5.26. So I get log 0.3 divided by log 0.5 times 5.26, which t is 9.136, so t equals 10 years. It should say decrease to at least 30%. And then we have these ones. These are all algebraically ones, right? Exponentials can be converted to logs if they only have one exponent. Logs can be converted to exponentials if they have the variable beside the base or beside the in the base or beside the log. But if it's exponential, the very first thing I am always going to do is try and do common base. This one here is the hardest common base I could possibly give you, and I'm starring it just because I don't know if they'll ever give one like this, but heaven forbid I not show it to you and then you get it wrong. Now I can't divide the 4 over because the 32 has an exponent, and I can't multiply the 4 into the 8 because it has an exponent. So I have to make them all just be separate base 2's. So this 4 is going to be 2 squared. Start so you know how to do it. The 8 is 2 cubed. So I actually have to make them all be base 2 because I can't move that 4 over the 32 or the 8 because they both have exponents. And 32 is 2 to the 5 to the 2x minus 1. So here I'm going to get 2 to the 2, and then 2 to the 3x plus 3, because you distribute, equals 2 to the 10x minus 5. Now what do you do when you have 2 bases and 2 exponents? What do you do with the exponents? 2 bases that are the same. Nope. You add them. 2 bases and 2 exponents, when they're the same, you add your exponents. So you're going to get 2 to the 3x plus 5 equals 2 to the 10x minus 5. And so I'm going to get 3x plus 5 equals 10x minus 5. Subtract 3x. 5 equals 7x minus 5. Add the 5. And all of these solving ones, we can y1, y2 and check, so when we have the test, we should know if we got them right or not. This one we can make common base of 4. This is 4 to the 3. This is 4 to the negative 2. So we'll get 4 to the 6x plus 3 equals 4 to the negative 2x plus 4. 6x plus 3 equals negative 2x plus 4. Whenever there are two exponents and I ask you to solve algebraically, the only way you can do it is common base. Subtract 3. 8x equals 1. X equals 1/8. This one you'd have to divide the 4 over, then convert to a log. So I get 3 to the x plus 6 equals 2. And when I convert it to a log, I'll finish these for whoever wants to see them because I'm not doing them tomorrow. Log base 3 of 2 equals x plus 6. Subtract 6. Log base 3 of 2 minus 6 equals x. X equals negative 5.4. This one I have to divide the 2 over. Log base x plus 1 of 3 equals 2. X plus 1 squared 3. Square root. X plus 1 equals root 3. X equals negative 1 plus root 3. .73. And then this one I have to convert as well.